Hi, Baji Baba. Baji Baba is live. We're live on the eve of St. Patrick's Day, and we have a busy packed day tomorrow with lots of different projects and work. And so we're here for a live stream episode to say hi to everybody and cover some topics. There are the kitty cats ready for you here. I hope that we get to say hi to many of you tonight, and that if you are seeing this later on as a video upload, please do like, share, subscribe, leave us a comment so we can catch up. Hi, Baji. Hi, beautiful. I missed you. Hello, Javier. How are you doing? We're live. I wanted to start the live showing you guys Baji because, hi, Fuji Babu. And there is Suji Mama, because I know some of you have been wondering about him. And so don't you worry, he's here. He is here. But when I sit down, I'll probably have to turn the camera to the direction of the windows. And if Baji takes his perch by the window, then you will see him. The very worn down, worn out cat tree. Baji Babu! Say hi, Baji. Everybody missed you. This is Baji and Physics, where we cover physics, astronomy, astrophysics, cosmology, and we show Baji and his siblings. And we also cover physics, and we show my face momentarily. Baji, are you quite ready, Baji? Ready, steady? Here's gonna be the needle. Here's gonna be the needle. These are the lights that we use for the live, by the way. And this one's bulb is out. So there's only one light, and that's why it's been slightly darker than usual. I hope that that is okay. Welcome, everybody. Please join us. Welcome in. Like, share, subscribe. Okay, I am going to set up the live on my laptop here. Javier, how are you doing? Tell us how your day is going. Very beautiful. Have a good night. Oh, hi, Devin. Thank you. Well, I hope you catch us later on. You can see the episode later on once it's uploaded as well. And we might have to make it a little short tonight because, hello, because we have a very packed day tomorrow. You're good. Just hit the hot weather. Oh, the hot weather. Where are you? Where it's hot already. In Boston, it was much warmer today, but we have had thunderstorms all day. I went to the gym. I actually took an Uber because I have no car. And I got a really good deal on Uber. But then on the way back, I caught the bus. And I did have to wait in the rain under a tree. This tree did protect me from the gusts of wind and rain. And I am happy to be back home now. Thank you, universe, and evil eye remove. Baja, California. Oh my goodness. Hello, Wild Wavy. Hello. Baja, California. So that is already very hot there? Goodness. There was a Fuji Baba. Can you please like the live? Thank you so very much. We are here. We are here. Welcome one, welcome all. Come on in to the live. We will be touching upon our favorite topics in physics, astronomy, astrophysics, and cosmology. We also showed Baji, who is accompanying me for today's lecture. He's on the sofa. And this sofa, by the way, we found it on YouTube Shopping, and sometimes we tag the sofa as well. It is a participant in these lives. We will be covering those things, yes. Oh, goodness gracious. Hello, Paxton. Hello, Jimmy, James. Hello. Hello, Prince of Judah. My favorite scientist on YouTube. Oh, thank you. I'm so glad that we made that list. Way too deep. Stick with nonsense. Oh, my goodness. Hmm. So, by the way, I'm here. Let me show you guys my dress. I have made the effort to wear one. I was in my gym clothes earlier, and Shalom, how are you? How is New York? How is New York? This is the first time I'm wearing this pendant that I got for myself. I think it's malachite. I got it from a gift shop. Oh, I'm so sorry. You pronounce Baja like Baha. I was going to say that that sounds a lot like Baji, who lives here. Hello, Effie, Nip. Staying off the grid, hello. Javier is saying yes, Lo. She is a scissors. I don't know what that means, but okay. A scissors. Sometimes I use a scissor to cut something. Um, my mod is here. You might want to tone down any inappropriate things you're saying. Half the time I don't really get it anyways. And uh the mod will probably get rid of it. So you're wasting your energy. But do divert your energy to our topics of tonight, which is going to be physics and kitty cats. It's $1,000,000 for an interview. Okay. Hello, Damon. Hello, Pranay. How are you looking? How am I looking? I don't know. I've gained some weight. Hello, Gary. Who is this person? Nicholas. Hi. You're an eyewitness. Physics and kitty cats. Yes. Hello. Yes, if you go to the beginning of this video, you will see kitty cats. What's your ethnicity? Tie a piece of... Okay. Hello, Connor. Hello, Nolan. I think you look perfect. Oh, thank you. Thank you, Javier. It's okay. Sometimes people call me fat. Fat is not ugly, though. There are kitty cats here. There's no doggies in the house anyways. But I did grow up with my grandmother's dog. And so I'm a dog lady who is a cat mother. Thank you for being here, Paxton. Sometimes people like to get it out of their system and call me fat, and that's okay. Fat is okay. We just want to be healthy with the grace of God and the thanks to the universe. Touch wood and evil eye remove. Aw. Hello, James. J Devil is saying you're gorgeous. Aw. Aw. Thank you. Oh, can you please subscribe though? Fat, thin, ugly, beautiful, pretty. More than all of that, what helps me out is if you could please subscribe and like and share. Chapel Hill, hello! Hordes Coffee, Fernando. I have been to Chapel Hill. I went to NC State myself, so go to Hell, Carolina. Tar Heels, we are better than you. The Wolf Pack. Good looking nose. Hello, Fernando. Jenna. Thank you. Thank you for all the hearts and thank you for all the hearts and emojis. Thank you guys. And some very interesting comments as well as the regular comments. Thank you. Hello, Funsky. Hello, Meet the Beat. Hello, J Devil. Where are you from? I'm in Boston currently. Please subscribe. Thank you. Did you see the Oscar? I did not. I went to Back Bay and I did filming for TikTok the entire evening. I was covering tourism and hotels and landmarks. So I cover it's the heels. Okay. Hello, Logan. Where is Steven? I don't see him. Oh, Steven, hello. Hi, Ben. Hi, everybody. Will you consider starring in films? Of course. Depends on the script and the pay. It has to be the bang for the buck for me. I'm interested in short-term projects like that. It doesn't have to be permanently, you know, a job. Hello from Hollister. Hello, Mario. Oh, that's right. It's a more decent time in California right now. It's like 9. Hello, Mario. Mario is saying, you have a beautiful smile. I got my book. Oh, good. Hello, Chris Barnes. Barnesy. I will write the script. There is no pay. You will become a star. Um, hello, Feldmaniac. Go for it. You should email me the script and let me know how to work together. Where is your book? Okay, that's right. Stephen has his book. Go ahead, Stephen. All right, let me set up the live. I never did that because I always like to say hi to everybody, and that always gets me off track from the live sharing purposes. Hi, my dear. Hello. Hello, Didaji. Didaji? Jijaji? It's girls in here. I will type the script line by line in your chat. Welcome to everyone. Please subscribe. Yes, please. We need some subscribers, guys. Can we get 10,000 subscribers, please? Thank you so very much. Like and sub, guys. I really appreciate it. Please support this small creator channel. Completely homemade, grass-fed, roams free, small business, family business, small creator channel. Right here, right now. Please do. Please do like, share, subscribe, and tell your mothers, sisters, brothers, neighbors about this channel. So we can get 10,000 subscribers, please and thank you. It is lovely to see everybody, by the way. I made a goal. We do need gifts and super chats as well. We are a princess here. We're a passenger princess. We like when people appreciate us with gifts and super chats and and likes and subscribes and shares with all of the world. Please, thank you. Oh, and I will be showing you my dress. I'm not sure. I think I bought this from Amazon as well. I've been showing you guys my dress as well that I wear. The earth explodes in a fiery ball. Only the strong survive. My first line is, what the heck? I don't think I react like that usually, but I guess I'm a character now. Okay. What the heck is my first line? I will need to be acting. Can you pat your stomach? Hello, Tiffany. That's a strange request. I can pat my head for $500. Hi, Andrea. You might want to do an expensive super chat if you're going to be making any requests, and we will probably still deny them. Any requests. Oh, goodness. Where is my stomach? Thank you, everybody, for being here. Okay, let me show you my dress. Okay, so this is a very colorful dress that I'm wearing. It's a long one. It's very long. It's multicolored. The skirt part of it is multicolored, and the top part of it is this cotton, very comfy part of the dress. That's my curtain, which is a weatherproof curtain. This is very important. I know the color is clashing with everything, but this is the curtain of use in the wintertime here, so don't hate on it. Uh, it is one of those, what do you call, thick curtains that keeps the insulation happening. So, anyways, and then this is a black little jacket I have on top. Now, I'm wearing this dress here at home because it is actually torn. This material, which is a synthetic material, not a cotton material, which my preferred material, textile for clothing is cotton, or silk. Uh, but this thing. I don't know if I bought this dress on Amazon. I might have, probably did. There is a gigantic slit on the side of it. So when I what do you call, when I go out and about, I can't really wear this dress. Why? Because where's the, I'm not about to show the entirety of the, oh, wait. Where is it? Oh, it's been stitched a few times. Um Now I can't find, okay, where is it? There is a gigantic tear on this dress, but now I can't find it. Okay, that's weird. Anyway, this dress tears very easily, and it's been stitched a couple of times by my mom because I don't know how to sew because she didn't teach me because she wanted me to dominate male dominated fields. So anyways, oh, wait a minute, I think she stitched it. I've been a member. Oh, hi, Steven. Are you a member? Oh my god. Oh my god, I think it's gone. Guys, wow. I'm having I'm having a discovery moment here. She stitched it. Oh, thank you, mother. I don't know who stitched this, my dad or my mom, but look at this. So anyway, what I wanted to say is that this dress, it does tear. If I walk too fast in this dress, it does rip on the sides because there's just a thin stitch on the side, on each side, and this like synthetic material. But anyways, it's been stitched on a couple of times by my parents. Whenever the whenever they visit, they stitch a couple of things here and there because I don't really like shopping. We don't really like I don't really like buying clothes constantly, so I'll wear the clothes that are torn. And so because they didn't want a surprise slit on my dress, I think they stitched it. And I was wearing this at home only because it is torn. Anyways, that's the dress, guys. That's the dress. Uh, I don't know why I did that. That's a tick. That's a tick. I wasn't trying to make any music. Um, I'm still shocked. I'm in shock that the dress is stitched. Blessed. Hello. Are you USA? I am USA. Hello, Mystic. When hydrate is cast, everyone, including the chat, should consume a sip. Oh, we should have water, yes. Are you Indian or Colombian? Stephen is my first member. Of course. You got a silly laugh. I can't see your legs then. Great, you're amazing. Oh my goodness, Stephen. Stephen has been a member for 9 months. Hello, Indri. Where's the free seminars? My ignorance is winning the fight. We will start our topic momentarily. Thank you so much. I just had to get the dress out of the way. This stream got super. Oh gosh. Hello, Feld Maniac. Spring is in 2 days. You have extra vision. Well, I hope not. Hi, beautiful. Hello, Neil. But yeah, isn't that crazy that I looked for the tear on my dress and I could not find it? I think my parents did stitch it. It's just, I just thought that I tore it. And it's very shocking to me that, in fact, it is fine. Okay. So this is kind of like discovering a new dress, guys. I went shopping in my closet. I put on a dress. And I thought it was torn, and it's not. I think we should treat our clothes in this way because that is better for the earth. Did you know that the fashion industry is causing too much pollution? And don't throw your dresses and clothes away. Recycle them, put them to good use, donate them, things like that. I've donated a lot of clothes. Every time I've moved, I've donated a lot of clothes that I no longer wear. But sometimes you can actually go shopping in your closet and find a new dress, which is an old dress, but you haven't worn it in a while and you've completely forgotten about it. And it could be that you think it's torn, but it's actually not. And it's a perfectly good dress. I just hope it's not torn in a spot that I'm not expecting. You love new dresses. You're absolutely gorgeous. Oh, well, thank you. And thank you to the universe and God and genetics. Hello, Nathaniel. What do I have to understand? Where is your previous message that I've missed? Nathaniel is saying, do you understand me? Rodriguez? I do understand you, I think, but you might want to ask the question. How old are you? My closet is out of new dresses. Is all out of new dresses. I prefer women in dresses. Okay. Well, I like to wear a dress. I like to wear a dress because it's easier to get dressed when you're wearing a dress. When you have to like do tops and pants and stuff, then it's a lot of decisions to make. Whereas a dress, you just throw it on. You throw it on and you're good to go. And I just wear this jacket on top because this dress is actually sleeveless. And so it has no arms. So yeah. Anyway, okay. We will now, where are the kitties? Well, Baji's right here on the sofa. Stephen, you missed the beginning of the live. We were showing Baji and the kitty cats at that time. This is the dress. Right here. See? I feel like I'm finishing getting ready at this point. Okay, so we will now discuss certain things. We will now discuss certain things, such as physics and astronomy and astrophysics and cosmology. So now, if you have if you're new here, you should subscribe because some of these topics we actually kind of continue on from the last time. And so if you're, joining in the middle, it may feel a bit abrupt and confusing, but don't be shy and don't worry too much because once you keep coming back to the lives, things actually get abundantly clearer. So don't worry if something is a little confusing at first, it will clear up soon enough. Okay. And thank you so much for the likes and comments and shares and subscribes and things like that. Really appreciate it. Don't put your hair behind your ears, it will force your ears outward. That's okay. It's gonna be okay. It is gonna be okay. Um, okay, so we said dark energy in the title, but actually we will continue with the topic of neutrino experiments. Now, Ben, you were here when we were doing that, right? If you're a cosmetologist. So it's a cosmology, actually, not cosmetology. Um, should we do dark energy or should we do the neutrino topic from last time? Huh, huh. I think we will continue with Anita. You want to do dark energy? Okay. Okay. We can do dark energy. Um, that's very true. The one and only Nicole is saying her makeup and hair would be better if she was a cosmetologist. That's true. Those skills are outside of the scope of my background. What are you, a physicist? Yes, indeed. Aw, she doesn't need makeup. So the men here always say that I don't need makeup, and I think the women uh point out that my hair is not done well and that my makeup is also lacking. So that's okay. Different people, different opinions. So we can we can do dark energy. Let me do dark energy actually. I don't think we have covered it from this book. I want to use a good reference. When we've used dark energy from the my cosmology book, it's been a little too much. Um, so I kind of want to see if this is any better. Um, it's very short. It's very, very short. Oh, thank you. Hello, Mike. Love you as we should all be. You don't need makeup, you're beautiful without it. Oh, thank you, Jean. So actually, I don't know if I like. I'm looking at this book. Um, Foundations of Astrophysics, and You know what? Let me cover this. I think this is something that we haven't quite we've touched on it, but we haven't really covered on it. Okay, so this is going to be from Foundations of Astrophysics by Barbara Wright and Bradley M. Peterson, and it's going to be about the early universe. Okay. Um, I like Asimov. I've read a few of his science fiction writer there, Isaac Asimov. I'm not much of a science fiction reader, more of a science reader than a science fiction reader, probably. Thank you for liking the live. Oh, I'll put it, I'll tag the book. One second. Um, can I do witchery? Probably. So remember that we have talked about cosmology here before. We've talked about the Big Bang, early universe, evolution of the universe. I think this book became out of stock. I've had trouble finding it lately. But the authors are Barbara Wrighton and Bradley M. Peterson. They're actually my professors from the Ohio State University. They are, oh, I'm actually going to see them this summer because I'm going to a conference. Hopefully, I'll be able to share from that conference as well. But yes, the book is written by Barbara Wrighton and Bradley M. Peterson. I put it in the chat, the names of the authors. And Barbara Wrighton, both of them, I believe, have multiple books. And they are the authors of very standard, very well known um, university astronomy or astrophysics books. The books that are used to teach what you may call the majors of astronomy, astrophysics, and whatnot. I had this book in my list earlier as something I could tag, but I don't see it anymore, which means that it might be out of stock and has been removed from YouTube as something that I can link to. But that is not to say that the book doesn't exist. I'm sure it does elsewhere. It's a very well-known book, so I'm a little disappointed that it is not here where we can find it. Boy, oh boy. Well, um, I found this book, this one. We've also covered a lot from this one, this Neil deGrasse book. So tag that for now. Although that's not the book that we're currently really studying from. Do you think man could ever live on Mars? Mars is not the worst. Mars has certain similarities with the Earth, which makes it a pretty okay colonizable planet because the surface of it is quite similar to Earth. I believe it has a lot of like basically silicon dioxide, kind of like sand, you know? So if you walked on Mars, I mean, your weight would be different because gravitation of Mars is less than on Earth because Mars is smaller, but overall experience could be similar. Mars also has a very similar tilt as the Earth. And so Mars actually has the same seasons as Earth, just longer because Mars has a longer year than Earth. The Martian year is longer because Mars is farther away from the sun than us. Mars is at 1.52 astronomical units from the sun. whereas we're like 1 astronomical units. Whatever the distance between us and the sun, we call that 1 astronomical unit. So Mars is farther away. Mars is also farther away than us, than Venus. So if Venus was a hospitable planet, that would be the planet of my choice. But it is not. It has a very thick, poisonous atmosphere, and it's very hot there. So Mars, better in that sense. It's colder on Mars, but to some extent, too cold is probably better than too hot. Um, so yeah, if you like cool summers and even cooler winters, Mars may just be the planet for you. And you just have to figure out, oxygen and being warm there. Bring a jacket, and then you should be good to go. And Mars does have some other interesting facts as well. The moon, yes, the moon is well, you can send a super chat, if not your heart. The moon is, very close, and the moon's surface is actually a little different. The moon does not have as much diversity in its surface as the Earth. So the moon is actually an older surface. It is something that does not have, you know, what do you call geodiversity as much. Well, geodiversity would imply the Earth, but it doesn't have as much activity. Like volcanoes and things like that. So pretty much, the moon is the moon. The moon is an older surface, and it still shows craters and things like that, which are that older uh, surface, not paved over by volcanoes. When is the physics cat merch coming out? Oh my gosh, that's a great question. Melvin O. Davy Z 4047. When is the physics cat merch coming out? That is so nice and encouraging of you. I will be coming out with physics cat merchandise. I think that you've prompted me to do an excellent thing. Thank you. Stay tuned for the merch. What should I do first? What are you interested in? Should I do a shirt, sweatshirt, hoodie, or some other item? What do you guys like, physical items wise? What do you guys like? Tell me. That would be a good thing to learn about you. Okay, I feel like I've been talking about Mars and the moon versus. Oh, you want a bikini? Your hair is beautiful, badass. Oh, thank you. Thank you. Thank you. It's not done very well, but thank you. And the moon caused the earth of 24 Indian vest. You want an Indian vest as the merchandise? I need something to drink beer out of. Okay, let me make notes. So, uh, Ben, can you put these in the comments later on? You want beer mug, vest, and what was the other thing? A bikini. Okay. My mod, my man, Ben Abraham, can you please put these in the comments later on if you can remember it so that I can also remember it? You want whey, like whey protein? I can drink coffee out of any beer device. Where's the book? Oh, you want cat ears? Aw. That's okay. I'm glad you find it entertaining, guys. Sam's. I don't know what that is. Like Sam's Club? I don't own Sam's Club. Okay, so somebody asked about Mars, so I had to answer the question, Feel free to move to Mars. Honestly, that might be a good move. And go all Martian. Go all the way Martian because I think Mars has potential. It has potential. Um, so not bad. Not a bad planet. My favorite planet after the Earth is, of course, Venus. I feel very strongly Venusian, but um, unfortunately, Venus is not hospitable at all, at all, at all. So now let me give you a little introduction on the early universe, and this will touch upon the Big Bang, and some evolutionary stages of the universe. Now, of course, remember that the universe as we have it today is not I tried to comment on all your shorts. Thank you, Brick House. Please do keep on commenting and sharing my shorts. For some reason, I think my shorts don't get pushed out very much anymore, and I really appreciate your help. So now remember that the universe has changed a lot from where we came, the origin of the universe, which, there's a lot of support in various ways that the Big Bang theory is a good theory for the origin of the universe. Certain things are basically consistent with that theory as being the origin of the universe, such as expansion of the universe, the amount of hydrogen in the universe, abundance of elements in the universe, like hydrogen being the most abundant element in the universe, followed by helium, and how the beginning of the universe or the Big Bang gave us hydrogen and a little bit of helium and very trace amounts of lithium, where we can maybe not even mention it. And then pretty much all the other elements heavier than that came from stars. But in the very beginning, of course, we didn't even have stars. We didn't have galaxies. We didn't have stars. We didn't have any of these things. And we lived in a very different kind of, well, we actually were not here either, but the universe was a very different universe. We come much later. I don't know why I said we lived in a very different, I guess our souls might have been there, but not us physically. So the early universe, to understand the origins of the early universe, we want to look as far back in time as possible. So it's sometimes looking back in time also means looking a great distance away, but pretty much we think the universe is about 14 billion years old. So you want to have an understanding of what was happening then. And it's really a long time ago at this point. And, sometimes that can be hard, but we have found certain signature methods in which we can actually probe the earlier parts of the universe. Probably not right at the instant of the Big Bang, but soon after. And also, especially, we have a way to probe when the universe was about 300,000 years old, because we still have some leftover cosmic microwave background photons from an early time in the universe, where 300,000 years old is sounds pretty old, but in the scale of 14 billion, that's pretty early. So we have some photons from that time that is still kind of chilling, but that we can observe. It is isotropic, same in every direction, homogeneous to a large extent. So that is the sort of thing, for example, that one can use to study the universe in those early times. Your chat seems thirsty for your scientific beauty. Um, okay. Thank you, Felt Maniac. The Earth is the only planet who has a big moon. Yes. Um, no. So the Jovian planets have the other giant moons. Is that what you mean? The rocky out of the rocky planets, out of the terrestrial planets, which is Mercury, Venus, Earth, and Mars, I believe we're the only one with a giant moon. But of course, the Jovian planets, which is, of course, Jupiter, uh, Uranus, Saturn, Neptune, those planets have the other giant moons, including, of course, Titan, right? Is your physics And the moon, because the Earth have 24 hours. Indian vest, beer mug. I can be focus on critical thinking. Hello, Shadow. Yes, ma'am. Hello, Garu. It's too bad. Dark energy remains one of the greatest mysteries in cosmology, appearing as a vacuum energy or a cosmological constant in Einstein's theories. Yes. Thank you for the comments, by the way. This is helping you sleep. Okay, good. Keep your eyes closed and you can listen to this like a background. Um, that's almost older than Biden. You guys are funny. Okay, so we'll keep going from this book to see what they have to say. The oldest photons we see today are the photons in the CMB. So these are the photons that I just mentioned, the cosmic microwave background photons, from when the universe was kind of chilling at that age of around 300,000 years old. So when the initially hot and dense universe became sufficiently cool, because initially universe was very hot, very dense, very energetic. Photons were king of the jungle. Photons are of course light particles, particles that make up, light, the particle nature of light. And these things were just constantly bouncing off of each other, especially photons, electrons, positrons were constantly in a interactive with each other cosmic soup. And at some point also the universe was expanding, so at some point um things cooled enough, cooled down more from that beginning time where it was very hot and dense, and the picture became a little different. Okay, so we'll read about that. So when the initially hot and dense universe becomes sufficiently cool, protons and electrons combined to form neutral hydrogen atoms. So the first time that we're able to have neutral hydrogen atoms is when the stuff kind of cooled down enough to have neutral hydrogen atoms. Before that, pretty much whenever you hear about hydrogen atoms or any atoms, really they're not atoms, they're more like the nuclei. They could be sort of the protons, the neutrons, the electrons, all kind of not really in a neutral atom. Okay, so this proton plus electron becoming a hydrogen plus giving off a photon, this type of interaction happened, and we combined protons and electrons in, with electromagnetic interaction finally to make the neutral atoms. So at this time the universe became transparent since the photons of the cosmic microwave background, or sorry, cosmic background radiation no longer scattered off of free electrons. So because So if the photons were constantly sort of in a battle with the electrons and positrons, basically these hot energetic photons were not letting the electrons and positrons ever have any chill. Okay, the moment you start to settle down, you get hit with the photon, right? So the very early universe was also called radiation dominated universe, and this is sort of the reason. Okay, photons were very important then. Photons, and you getting hit with a photon, whether you are an electron or a positron or something, was pretty much what was happening. You could not get settled down. You just couldn't. And you did not make any neutral atoms. Of course, we didn't have any galaxies, we didn't have any stars. We're just a cosmic jungle soup of hot energetic photons, and also there were electrons and positrons in the mix of things, and a little bit of the 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 protons and whatnot, stuff that will eventually make the hydrogen atom and some helium. So, but ingredients can exist, but if the ingredients are in a constant sort of getting interacting with each other in a way that doesn't allow you to form atoms, then we can't really call them atoms yet. But then the universe became transparent, since the photons of the cosmic background radiation no longer scattered off of the free electrons, because these electrons were allowed to finally interact with the protons and make neutral atoms. So as we look outward in space, we look backward in time. So the farther away we can see, that is the farther away in time that we're also seeing backward in time. So in astronomy, we do that. We do see back in time because light has a constant but finite speed. When we do see some light, traveling to us and reaching us from some source, from some object from a long time ago, well, we are looking at the past. Okay, so even I am the past at this point. Like if you looked at me, light took some time to reach your eyeballs. You are whatever you're seeing is from the past in that sense. But this is really from the past, because of course in the scales of cosmology, the astronomy, astrophysics, the universe, um that past is more extreme. The When you look back in time, you could really be seeing the light coming from a very long time ago. Okay. Hello, El Hode Door. Um, okay, so um, we are surrounded by this spherical last scattering surface, which is the last scattering, meaning the last time photons scattered off of things, and then things cooled enough to form neutral atoms, basically leaves this signature, the spherical last scattering surface. The last scattering surface is where photons underwent their last scattering from a free electron before streaming freely through the newly transparent universe. So there was a moment in time when the last scattering happened. I mean, before that, they were scattering constantly. But then there was a moment in time, things had cooled enough where it's the last time that the photons have scattered off of the free electrons, and then neutral atoms have formed. um, and now the universe is transparent and the photons can stream freely from that last scattering. The last scattering surface is the surface of the glowing, opaque, ionized gas that filled the early universe. So, once again, the last scattering surface is the surface of the glowing, opaque, ionized gas that filled the early universe. The universe became transparent, and photons underwent their last scattering at a temperature of around 3000 kelvins. The scale factor at the time, so this is, by the way, scale factor has to do with the expansion of the universe. The scale factor at the time was 9.1 times 10 to the minus 4, corresponding to a redshift of around 1100. Just some details. So there is a model called the consensus model for the universe, and the time of last scattering was around, from there, basically, this model is basically calculating the time at that point, and this was roughly zero point 0.4 mega years. So that's where that 300,000 to 400,000 number comes. So this is basically the age of the universe at that time was around 400,000. I mean, 380,000 or so is something I've heard. Sometimes people say 300,000, sometimes people say 400,000, but that's pretty much that number coming from the consensus model. After you plug in the other things, you get this time. So this last scattering, because once again, scattering was happening constantly until things cooled enough to become neutral atoms. Then there was a moment in time when photons did their last scattering. We can see these photons, they've streamed freely, finally. And when you put together all the numbers in a cosmological model, you get the age of the universe to be around 400,000 years. So these photons are from when the universe was around 3 to 400,000 years old. Okay. Cold slows down physical matter with slightest mass. What do you mean by that? Are you talking about cold dark matter? What are you saying? What was before was the hotter and denser universe. The universe from its birth has been getting cooler and expanding. So, what was before is a younger universe that was hotter, denser, more energetic, and lots of interactions happening constantly without any neutral atoms. Good question. You must have loved that show, The Big Bang. Not really. I mean, I like it, but it's a show. I don't have the patience to like really watch all the seasons. I've seen some of the episodes. But probably I stopped because I don't have the patience. Rocks are trapped photons. So rocks are made of ordinary matter, which are made of atoms, which are made of nuclei and electrons. Nuclei are made of protons and neutrons, which are made of quarks. And the electron is a type of lepton. So that is to say that rocks are made of atoms, which means that things at some point, of course, on the earth too, right? Um, the earth could have been just molten lava everywhere, but the earth also did a process of cooling from when we were first getting started as this solar system. The earth is like 4 billion years old, and it has had time to cool down, or we could have been very different in the earlier days. Even the earth was very different, right? So, so how do I put it? Basically, when things are hot, dense, and energetic, electrons, positrons, the particles can get, even other particles can get bombarded with photons and absorb that energy from the photons. Because, by the way, photons have an energy which is given by the Planck's constant, which is some number h times f, which is the frequency of the photon. So the more frequency, the more energy. So a really angry photon could impart its energy and give you some energy, but a really more angry photon will give you even more energy. So and we also know about mass and energy equivalence. So yes, part of it is, you're right. Photons, the energy of photons can then make uh electrons, positrons, or other pairs that are heavier than electrons, positrons. Um but also I want to note that there's these things called quarks, and those stay together because of the strong nuclear force, which is kind of a different topic and a different force than electromagnetic force. It's completely different. So that the quarks are also to be noted when you consider a rock, for example, because electrons, positrons, because positron are just the antiparticle of electron. So if you basically have a photon making electron and positron, it's going to be electron and positron, because electron and positron can annihilate to make a photon can annihilate to make electrons and positrons, so that type of thing. So because a photon has no charge and electron and positron have opposite charges, so charge symmetry that is maintained. But basically, when you consider a rock, there is more to the story than photons, electrons, and positrons, even though that is part of the story. But basically, a rock, again, has atoms which have nuclei. Honestly, the mass of the atom is really concentrated in its nucleus. So, because most of the mass is in the nucleus, right? So, that nucleus is made of protons and neutrons, which are composite particles, made of the more fundamental particles called quarks. The Big Bang actually made some of these as well. They were not the most dominant thing to begin with, but the Big Bang actually did give us, we're going to actually read about that in just a second. If there's a topic called Big Bang nucleosynthesis, and this is where we basically talk about these quarks. I mean, uh, often they're just called nuclei or protons or neutrons and things like that. People are not spelling it out as quarks, but you have to keep in mind that neutrons and protons, which make up the nucleus of atoms, are composite particles made of quarks, and these are different than the electrons, positrons, and photons. Okay, because electrons, positrons, photons, they do the electromagnetic interactions, but quarks do the strong nuclear force interaction. That's what keeps the quarks together and making things like composite particles like protons and neutrons. So the Big Bang nucleosynthesis is a process that also gave us a few of these. And because it gave us a few of these, we were able to have hydrogen nuclei and helium nuclei as part of the gift from the Big Bang. Because if we did not have any hydrogen and helium, then we would not be able to have nuclei and elements. And ultimately, later on, hydrogen and helium uh, made the first, the is matter, right? So made the first galaxies and stars, and then stars made all of the heavier elements. So just keep in mind that when we talk about matter, ordinary matter, and elements, we're really talking about nuclei. Nuclei are basically just protons and neutrons. Protons and neutrons are just quarks. Quarks interact through the strong nuclear force, which is a different topic than electromagnetic force, which governs photons, electrons, positrons. Okay, so yeah, so we want to have those things accounted for as well. Okay, so we will look at that. We will look at that, but all this scattering business, just keep in mind that in the early, like before this 300,000 years old universe, a lot of the, you know, a lot of the interactions were really between photons, electrons, positrons. That was the cosmic soup. The quarks were kind of less, if that makes sense. But we will read about it in a bit more thorough way than just describing that way. Um, Thank you, Fidel Torres. Thank you, Harish. Please do like, share, and subscribe, guys. That really helps me out. Please do like, share, subscribe, so we can continue these discussions and sustain our physics and cats channel. Oh, another thing that I did not mention much at all is, of course, dark matter, right? Uh, Dark matter is a mystery topic, something we don't know much about, but of course we know its gravitational effects. And we have discovered it in terms of its gravitational effects, but we don't know what the particle nature of it is. But I don't want to leave this out in the discussion of the cosmic story, because dark matter too is a cosmic ingredient. So we've basically touched upon the cosmic ingredients just in this brief discussion. The cosmic ingredients are photons, neutrinos, that's another type of particle, baryons, which is the ordinary matter, the neutrons, protons that I mentioned, dark matter, dark energy, and I would mention electrons and positrons. For some reason, they get clubbed under the ordinary matter. But I think it's somewhat misleading to do that because ordinary matter is mainly people consider the nuclei, which is the quarks, and quarks and are very different from electrons and positrons. Okay. And oh, another thing is that of course poor positrons, when they get annihilated with electrons making photons, would not have the positrons anymore. So we have more processes. It's a sort of a asymmetry that has led to us having more electrons in nature than positrons, because positrons are not anything too exotic or extraordinary, just the antiparticle of electrons. And so we could have had, well, if we had an equal number of electrons versus and positrons, then we would have, I guess, not existed, because upon annihilation, you just get photons and nothing else, but um, we do have actually more electrons existing in nature than positrons. And so you might not, be as familiar with positrons, but they are very mundane. They are just the antiparticle of electrons. And to the detriment of their fate, it just so happens that nature has kept more electrons than positrons. Hmm. Hi, Steve. Oh, somebody did a super chat. Acacio. Hola, amigos de las ciencias físicas, astronomía, cosmología, astrofísica. Did I say that right? What is the ciencias? Hola, amigos de las ciencias físicas, physics, astronomía, astronomy, cosmología, cosmology, astrofísica, astrophysics. Acacio! I got a super chat! Acacio, thank you so much. You have saved the day. Pumbafo is saying, Ondri B, are you AI? I am not! I'm the one thing that is not AI. You can tell by my hair that is not done and my makeup that is lacking. Nothing perfect about me here. So not AI. Ondri B, are you AI? I am not. Something more to look forward to. I've been missing you. Oh, well, you should just rewatch all of my videos when I'm gone. When I'm not live, you should be watching, rewatching, reviewing, revisioning all of my past lives and videos. JWST, James Webb Space Telescope. So Ben put a comment about the JWST, James Webb Space Telescope. Data produced unprecedented high-resolution maps of dark matter showing how it connects in a web-like structure that shapes the distribution of ordinary matter. Yes. So this is why I wanted to, this is what I was alluding to. We don't want to forget about dark matter because it may have a very important role. It probably does have a very important role in making the first galaxies, and encouraging and helping ordinary matter to collect and basically cluster to make the first galaxies and stars. So without which, of course, we would not be here, because all of the heavier elements, for example, out of other things too, but one of the biggest things is all of the heavier elements above helium are made in stars. We are star dust. We are here because stars have lived and died and spewed their materials, which contain the work of their life, which is the heavier elements beyond helium, into the interstellar medium, which then forms gas and nebula, which ultimately will condense it to make new solar systems or star systems like our own solar system, which is where from we come. So but the mystery has been that at least a few different mysteries. One of the mysteries is that, well, we know that galaxies formed because there was a time with no galaxies. This 400,000 year age universe didn't have galaxies, right? And now we have galaxies. I mean, we have the Milky Way galaxy. We can even see with our eyeballs other galaxies in the sky. We can see through telescopes other galaxies in the night sky. So we know we have galaxies now, but we didn't used to. So something made the matter to cluster and make the first galaxies, right? What is that something? Like, sure, gravitation won in some parts of the universe to make the galaxies, and because there is gravitation making things come closer, and there is expansion making the universe expand, and dark energy making the universe acceleratingly expand. So um, we basically the thought is that dark matter, this mysterious other matter, is something that may have helped um, to form the first galaxies. Okay, but I don't know. I'm not. We're It's a research topic, so I don't know for sure exactly how it did so or what is the story there. But that is the that is the thought. But anyway, thank you, Ocasio, once again for the super chat. I have missed you. Where have you been? And everybody follow suit. See how this super chat helps me so much? Um, Gravity is antimatter? Question mark. No. Gravitation is the phenomena of space-time bending because of a massive object. Antimatter is just another type of ordinary matter. Antimatter, that is the antiparticles of the particles, like electrons. Antiparticle is a positron. That is still just ordinary matter, okay? Just matter. It's just that we're more familiar with the matter part, and not we're more familiar with the particles and not as much with the antiparticles. Because remember, if there were an equal number of electrons and positrons and they had annihilated with each other to make just photons, then we would we wouldn't be here. We need an excess of electrons. So nature has found a way to keep more electrons than positrons, something that we are gifted with. And that has led to a more interesting universe. But positrons are nothing that special in any other, like they're not dark matter, they're not some other thing. uh they are part and parcel of ordinary matter. Okay, and gravitation is space-time bending, curvature of space-time due to massive objects. It's considered to be a fundamental um, force, for the lack of a better word, and it can be approximated by Newton's laws of gravitation, and it affects us daily, and it affects classical mechanics, right? And you can do classical mechanics with the help of Newton's laws and classical equations without really using relativity. But if you want a more precise answer, then you would need to use relativity, and general relativity is the theory, upgraded theory for gravitation. And in that theory, gravitation is not really a force, it is a geometry of space-time, which itself, space-time itself, the four space-time, so four-dimensional space-time, one dimension for time and three for space. For space-time itself is curved by a massive object. such as it could be Earth, it could be the sun. When you're near a massive object, you will be experiencing the bending of space time due to that massive object. So well, the Earth, we're on Earth, but let's say the moon is going around the Earth. It's basically traversing a straight line in the geometry that includes four space time because Earth has bent space time to make the moon go like that. So that's gravitation. It's not antimatter. Hope that clarifies. Regiment. Hello. Pops is saying you're very beautiful. Oh, thank you. Time. No. Energy is equivalent to mass, and mass is equivalent to energy. Energy does not equal to time. Gravitation is the bending of space-time. We already know dark matter is super important. Good. How do I know? There's many ways to know. So some of it is theory and a lot of it is experimentation and measurements. So I went to school for this and I also worked in these fields is how I know. It's a lot of education, but we do experiments and we publish on them. So that is how we know. What is the universe inside of? The universe is the extent of what is there. If there's more things, I don't know of that. The universe is the universe. It's not inside of something. You know what I mean? As far as I know. As far as I know. Um, Fully formed galaxies. What do you mean by that? Fully formed galaxies from before the Big Bang? What does that mean? I don't think I catch that. I do believe in the Big Bang, unless there is evidence to go against it. A lot of the evidence goes for it, is in support of it. Mr. Drew is saying she's not AI because her hair is not done and her makeup is non-existent. Aw, I won't die until technology advances the full eye view because they keep drawing. Oh, he said, hello, friend of the physics and sciences realm. Hello, Wild. How do you view the transition from Lenin's leadership to his successors? I'm not sure what you mean. Making you think deep. That is very true. The fact that we can only see what light we can get is what's wild. That's actually something quite bothersome. The fact that, you know, the fact that the universe expanding means, I mean, at some point, like, there's going to be light that never reaches us, right? So it is true that we don't know a lot because there is going to be light that will never reach us, especially because of the accelerating expansion of the universe. And so that's going to mean that there will be things that we will never know. And we don't know what those things are. And when you don't know what you don't know, that is truly troublesome. Hi, Nicole. There's the smartest. Oh, thank you so much. From Seattle. I have never explored Seattle. I want to, though. Do you have recommendations? A massive lopsided cloud of antimatter, specifically positrons, exists at the center of the Milky Way, spanning roughly 10,000 light years and emitting intense. So positrons can be in the black hole. So actually, by the way, we've also talked about a while ago. We talked about how black holes can have a temperature. It's actually quantum mechanics and the fact that, you know, there could be like pair production of particles, like particles and their antiparticle partners, and things like that lead to sometimes a particle kind of escaping the black hole due to the uncertainty principle. And that is i- actually how we end up with black holes that have, with the temperature of black holes, the fact that black holes are actually uh, radiating some energy and have a temperature, the Hawking radiation. So we talked about that, utilizing, of course, his book, Stephen Hawking's book. Discovered in the 1970s, this fountain produces energy equivalent to 10,000 suns, likely fueled by stellar explosions, neutron stars, or black hole binary systems rather than dark matter. That's entirely possible. The center of the galaxy does have. What is the composition of your soul? That's a great question. I don't know. That's something we could explore. So somebody said gravity is a byproduct of the electromagnetic force. I'm not sure about that because gravitation is much weaker than the electromagnetic force, and it's also always attractive. Whereas the electromagnetic force, of course, is sometimes attractive and sometimes repulsive, is what I was going to say. But are you saying that somehow it's like an averaged out kind of electromagnetic force? I I don't think that is right because so I don't know, something like gravitational lensing also makes me think that gravitation is its own thing. I don't know. I don't know. But you know what? Gravitation is a mystery as far as being explained by particle physics. So as much as I say that gravitation is the theory is general relativity, so I understand what general relativity has to say about gravitation, but at the same time, we don't have an explanation of gravitation in particle physics. So I'm open to learning more. Please do subscribe and share and like and thank you. And let me know your thoughts and information. I'm learning too. It's all relative. There is no space time, but there is in general relativity. So if you're saying that general relativity is wrong in some sort of way, that's completely fine, but you may want to back it up with something solid and tell us where it's wrong and why many predictions of general relativity have come true, including but not limited to gravitational lensing and gravitational waves that we have now started to measure from collisions of black hole, or neutron star, or neutron star, black hole. Okay, so the fact that we measure gravitational waves and those were predicted by general theory of relativity, and the fact that we, the gravitational lensing. But something that you said does make me think, however, but I don't know. It's true that that gravitation is not explained by particle physics. So I'm open to new ideas. I basically go to bed early. I usually watch you on delay. Oh, thank you, Acacio. Oh, hi, Anthony. Oh, really? Shooting stars everywhere? Okay. I don't really keep track of our solar system much. I'm kind of unworldly in that sense. Why don't an object collide into more massive object according to Newton's universal law, as more massive object is directly proportional? Are you saying why hasn't like the moon like smashed into us? Because so according to Newton's laws of gravitation, the gravitation does depend on mass, but also depends on the it's inversely proportional to the distance squared. So both of those together make the force quantity the way it is and keeps the moon in orbit. Okay? But in general relativity, actually, the way it works is that the Earth's mass and the Earth's gravitational field, or however you want to say it, the Earth is bending space-time around it in a way where the moon ends up being in orbit. Thank you, Javier. Thank you, and see you again. I don't know about the whole afterlife thing. Fun ski. Did CERN mess us up? I don't think so. CERN is just doing some experiments. I don't think there is any mess that I would be worried of. Hello, Adam. Hello, Wild. Apparently, Jupiter has a lot of mass. Are you talking about something else? Jupiter does not have rock, but it has a lot of mass. Okay, this is very hot and a lot of gas. It actually, do you want to see what Jupiter has? I have a picture. I'm enjoying you guys' questions today, so I feel like I didn't um, progress into the topic as much, but your questions are delightful, just delightful. So Jupiter, since you asked, has some layers. It is true, but where is the picture that shows the core? I want to see the terrestrial planets. Jupiter. There it is. So Jupiter has actually a core, which does have rock, but then it has ice, actually, like not just ice as in water ice, but other materials ice. Then it actually has metallic hydrogen. Would you believe it? Because metallic hydrogen is, of course, a very different hydrogen than what we are familiar with. And then it has molecular hydrogen. So Jupiter has some layers. I will show you the picture as well, but um, it has a ton of mass. It's very hot. And it's a very different environment than what we are used to. But it does have some rock at the core because of pressure. Um, and then it has a bit of ice. Then it has a ton. Most of the layer, actually, or most of it, is the metallic hydrogen. And then it has the molecular hydrogen on top. That's the layering of Jupiter. And so let me tell you about metallic hydrogen. So at a pressure of millions of atmospheres. So this all has to do with the pressure on and in Jupiter. Whatever atmospheric pressure or whatever pressure you're used to here on Earth, just forget it because Jupiter has way more. Okay. So Jupiter's environment has so much of a different temperature, pressure, all that stuff going on. It's so massive. Jupiter is sometimes called a failed sun. It is much, much bigger than us. And it does not have a nuclear reactor in its belly, but it does actually emit some radiation because of other reasons. But it's not a star, but it could have almost been, but it's not. So you need you need a different thermodynamic environment. You need an even much more extreme environment to be a star, which the sun is. Okay. So, at a pressure of millions of atmospheres, hydrogen becomes a metal. Because what's a metal? A metal is simply a material where the electrons move freely. So, a metallic substance is one in which a regular lattice like structure of positive ions is surrounded by a cloud of delocalized electrons, not bound to any particular atomic nucleus. So, metals, they can conduct electricity and heat really well. It's because the electrons are not bound, they can kind of move freely. So, that's what this is kind of saying. It's a lattice-like structure of positive ions, um, and it's surrounded by a cloud of delocalized electrons, not bound to any particular atomic nucleus. The delocalized electrons are sometimes called conduction electrons. You might be um, familiar because we are familiar with metals. Um, And so those electrons are what gives metals their characteristic properties. Metals typically are reflective, good conductors of heat, good conductors of electricity. And both Jupiter and Saturn, which are, the biggest planets, have high enough interior pressures to have layers of liquid metallic hydrogen. However, because Jupiter, with its much higher central pressure, has a much greater amount. So, pretty much, Jupiter is like a very outlier kind of planet in our solar system. Nothing is like Jupiter. Saturn has some of the same things, but Saturn is still a lot smaller than Jupiter. So, Jupiter is like mega mega planet of this solar system, and a lot of the features of it are quite unique. For example, this huge amount of metallic hydrogen. So yes, Jupiter has a ton of mass, just not similarly arranged like on Earth or in Earth. Do you consider time as a separate dimension? I consider time as one of the four space-time dimensions. I consider time as a dimension in the four dimensions of relativity. Um, Hello, band. Everyone has a twin. Something is connecting us. Okay. School and education can be a hindrance. Uh, Thank you, Ben. The James Webb Space Telescope studies dark matter indirectly by mapping its gravitational influence on visible light and galaxies. I like that. Can we get 100 likes? I also might have to sign off soon here because I have a very long day tomorrow with all kinds of things going on. You can't know a theory is true. Cannot believe they don't teach you this in school. So you can actually know if a theory is true because you can test it. Did you know about that? Testing a hypothesis? You can do that. Feel empowered to do more measurements and testing. This may change your mind about how science works. If gravity is not infinite, I don't know what you mean by that. Okay. The universe. By observing how dark matter's gravity bends light from distant galaxies, a process known as gravitational lensing, JWST creates high resolution maps of the cosmic web. Space is space, it is emptiness, there's no end to it. Um, okay, Bill Clancy, something in motion. Thank you, Charles, for the gift. Something in motion tends to stay in motion unless action on. So I think cosmic web, the thing that you are talking about there is dark energy. The thing that's responsible for the accelerated like expansion of the universe is not dark matter, it is dark energy. Another ingredient of the universe that we have spoken of quite a lot. We didn't go into it much today, but that's another thing. How did the universe start? The Big Bang, which is not necessarily an explosion, but there's a theory which is called the Big Bang theory, and that is how we think the universe started. Hi, Princess Tiara. M3W is saying, I think we humans were made by Earth so that we can eat fried chicken. We were made, the stuff we were made of was made in stars. And then the stars died and spewed their materials to the interstellar medium, which then gathered and went through some stages to condensate, which is kind of got cool enough, then got hot enough to do some things thermodynamically, which then created the solar system of the sun and its planets. So that is how we came to be. Because, we have things, we have gold on the earth, for example, and gold is not made naturally just like that. You need some hardworking stars doing their thing to make gold. Okay. Our sun, for example, mainly just makes helium from hydrogen. But we have elements on the earth that wouldn't have been that was part of that rich nebula that we come from. Pluto is a dwarf planet. It is a planet in the sense that it is a smaller planet. So It's a it's not considered a planet. It's just considered a dwarf planet, which has um which has a different definition because it didn't quite meet the criteria for being a planet. The multiverse could be true. I don't know about that one. Let's reach 100 likes. Yes. Thank you for the floating heart. Oh, thank you so much. I like that. The lucky clover. St. Patrick's Day themed. Thank you, Trey Brown. Trey Brown 235 sent a lucky clover. Thank you so much. I really appreciate it. Javier is saying, I love you, good night. Thank you. Love you too, and good night. I guess I'll do my own research since you can't answer simple scientific data. How hard is it to tell me what the atomic weight of metallic hydrogen is? Hi, Eric. Tell me a joke and I'll sub. Um, are you joking? There, I read one of the comments, which I think is a joke. There, I told you a joke because Kenny Lee told a joke and I read it. So I think that counts as telling a joke. He's telling more jokes for planet Earth, and so so metallic hydrogen has the same has the same atomic weight as normal hydrogen. Okay, it's still the same element, just metallic. Um, mm, 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 mm. You wove me? Wove? Are you a genius? Hello, Eric. Hi, Prince of Judah. Thank you for all the questions tonight. Steve is saying, why are you so pretty? Thank you. What about Albert Einstein is true? So even some of the things about the early universe, I'm still talking about the observation thing, we can still observe. You don't have to be present in the same time to observe a thing. I hope you know that. We observe things from the past all the time in astronomy. It's very um normal life. Normal life in astronomy is to just is to measure things from the past. Hmm. Neutron stars. Quit being a weirdo. Tachyons are infinite speeds. What is faster than light? Um, thank you. Yep, yep. They're good with thanks to the universe. And oh, by the way, here's my lucky clover on my finger. Somebody sent me a gift with which had a lucky clover, and I have one too as a ring. I can't, some of the comments I'm not able to catch, so you might have to bring them. If I didn't catch your question tonight, you should ask it again next time. And sorry about that. If I didn't catch you tonight, I hope to see you next time and your question next time. But let me look on my, and actually, let me change the title. We did not really talk about dark energy today. Where are you from? I'll let you guess because people love to guess that. And also, I think people know pretty much. So guess, guess, guess where I'm from. Any last questions, comments before we say goodnight? How is everybody doing? Thank you guys. Thank you again, Ocasio. Thank you, Nicole. Thank you, all my mods. Thank you so much for all your help. India? Eastern India? Eastern India? Yes. That is where I'm from. And I live in America. Yes. Both are correct. America is correct. India is correct. All the things are correct. When we're studying the heavens, we're studying a kind of history. Yes. Are you a Starbucks chick? I mean, who isn't? I don't go to Starbucks every day, but I do get the occasional Starbucks. Thank you, Damon. Thank you, Damon. I'm changing the title of this live. Give me a second. But no, I don't get Starbucks every day, though. I don't know if that helps. Thank you. Yeah, I do have a little bit of work that I have to finish and go to bed. And then tomorrow I have a lot of things I gotta do and finish up tomorrow. See you again soon, hopefully tomorrow night. Hopefully I'll see you tomorrow night and we can continue with our topic and bring all your questions again. It's been lovely. It's been lovely to hear from you. Okay. I'm going to call this Early Universe Chat and your questions. Like and subscribe. I have to do a picture. I didn't do a picture today. Ben, how is it going? Are you adjusting to the time? Shalom, shalom to all. Yes. How are you doing, Ben? Thank you. I like being here on the lives with you guys, though. Thank you, Randall. The number one top fan is, of course, Acasio because he did a super chat. Thank you, Acasio. Number 2 is Funsky. Number 3 is Ben. Number 4 is Mr. Vision. Number 5 is Feldmaniac. How lovely. Thank you, guys, indeed, for all your supports. And don't unsubscribe. I feel like people have been unsubscribing when they see my shorts and premieres that are videos where I'm not live, but please do when you come across a video or a short of mine, please do like and comment. And I look forward to seeing you on a live. But try to tolerate my other content as well because those help me too. And the videos, and the shorts are important. I feel I feel I feel like you're new to the channel, please subscribe. Okay. Oh God, this thing. I'm glad I didn't touch my laptop too much because sometimes that makes my life go away. Good night, guys. Good night. Sleep tight. Really appreciate everybody being here tonight. Mwah, 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 mwah. See you tomorrow. I have a long day, but I will try my best to be here tomorrow night as well. Okay. Good night. Sleep tight. Really appreciate everybody. I have to refresh. Mwah, mwah. Also, please share the live if you could, and leave me a comment if you're seeing this later, and tell your neighbors, tell your friends about the channel.